Let's try and understand volume of distribution and why it's important. So imagine you've got a container and you've got fluid in the container. There's 1 litre of fluid. You just happen to know that. And then you take a chemical and you take 10 grams of this chemical and you dissolve it into this fluid. You have a device which enables you to measure the concentration. So obviously the concentration you would get here would be 10 grams per litre. That's fairly straightforward. Okay, that's fine because concentration is amount divided by volume. Now we could actually do this slightly differently. Let's say we didn't know how much fluid there was in this container. We don't know how many litres it is. Now we do exactly the same thing. We put in 10 grams and we find that it comes out not as 10 grams per litre, but the concentration is 1 gram per litre. Then we know that that implies that the concentration, the volume must be 10 litres. We can work it backwards. So it's the same with when we do the same thing with a human being. This time we have a person and they have a vascular system and we don't know the volume. So what we do is we inject a drug of known mass, let's just say 1 gram. And then we take our device again for measuring. So here's our device. And we can measure the concentration and it comes out to 0.1 grams per litre. We know it's 1 gram, so that implies that there were 10 litres. If it had come out to 0.01, that would imply 100 litres. So this here is what the volume of distribution is. It's the volume that we get when we use this method to work out the amount of liquid that this stuff got dissolved into. That's the volume of distribution. Now you notice that this is ridiculously high. It does not equal the plasma volume because some of this drug, for example, might have actually got stuck, perhaps absorbed and bound to sites here. So we end up with less in the actual bloodstream, and so the concentration goes down, which means that we overestimate the volume. So the volume of distribution tells us what the volume would have been if it had been completely dissolved. Of course, if there's a high volume of distribution, much greater than the volume of the plasma, then that implies that we might have binding, or we might have some sort of hiding, if I can put it, hiding away of the molecule. Perhaps it might be in the fat. If there's no binding and no sequestration, another word for hiding, then the volume of distribution will be equal to the plasma volume. So then the volume of distribution tells us something about, gives us clues about where the drug is ending up in the body.